This is chapter 5, set E number 1, and we're told to go all the way back to example 10, which is on page 90. It tells us math SAT scores have an average of 535, a standard deviation of 100, and they're normal. Now, without them telling us that it's normal, we couldn't use the normal table. None of these formulas would work. So it tells us a person scores 750. What is their percentile? Now, when we see percentile, this means what percent to the left. Or like what percentage of people scored less than her. Less is to the left. So what percentage scored less? What percentage is to the left? I would draw a little picture to tell myself, okay, here's the 750. What percentage is to the left? That's what I need to figure out. Well, before you can ever find percentages for normal tables, you have to standardize. So we're going to do z equals x minus the average over the standard deviation. So x is the value you are interested in, which is 750, minus the average, they told us 535, over the standard deviation, which is 100. Now, when you put this in your calculator, you have to make sure you put parentheses around the top, or it's not going to give you the right answer. So it gives you 2.15 is the z value. That tells us that this person is 2.15 standard deviations above the average. So now I'm going to look up my normal table. My normal table will tell me the area to the left of any z value. So no z values are on the left side of each column. Then you have the areas. These areas are the areas to the left, which is what I wanted. So that's good. We don't have to do extra work. We're looking for z equals 2.15. So positive 2.15. It looks like I'm right here. It's even exact. I don't have to guess which z value to use. And the area is 98.42%. So this area, if I was to draw it again with z equals 2.15, this area is 98.4%. So the 98.4th percentile. Now percentiles are usually just rounded, which is why the book says 94th percentile, although the book rounds a lot anyway, so get used to that, it just rounds.